Awesome. Cool. So how is everybody doing?
Great.
That's not very... One more time. How's everybody doing? Awesome. This is an awesome city. This is an awesome conference. We're talking about APIs. I have a very tough lead to follow. You had Lego on the stage, and you had who I consider to be the Lego of APIs, who is Kin Lane, insanely exciting person. But I'll try to do a good job here. So my name is Irakli. I work for a group called API Academy at CA Technologies. And basically what we do is we spend half our time doing a fundamental research in the APIs, and 50% the rest of the time spending working with hundreds of companies around the world on the strategy, implementation, design, and the usability of APIs. So I'm going to share with you some of what we learn, and specifically I want to talk to you today about the topic that I'm really, really excited about: how to build APIs that last for a very long time. But before we talk about how to build APIs that last a very long time, let's talk about why is it even important. Okay, I'm excited about it, but why should you be excited, right? And if it is important, why is it important now? Why haven't we been doing this before? Or why shouldn't we wait 10 or 20 years to be doing it? Why is it important now? And a lot of answers to that question is on this graph, which is a graph from Cisco Systems. And Cisco, as you know, is the producer of all the backbone hardware that drives the internet. They collect a lot of data, and then they share that data. So according to Cisco, in 2013, there were 80 devices connecting to the internet every second. By 2014, Cisco is projecting that the number is going to reach 100 devices connecting to the internet every second. And they predict that by 2020, we're going to have 250 devices connecting to the internet every second. If you just add these numbers up, we're going to see that by 2020, we're going to have a whopping 50 billion connected devices on the internet. 50 billion. Let's put that into perspective, right? What does that mean? That means that for every human being in the world, there's going to be, on average, 7 connected devices. Right now, we have less than 1. It's going to change how we live, how we interact with the environment, and most importantly, how environment interacts with us. It's also going to change how we write software with 50 billion connected devices. You see, the truth is that for decades now, we in the field of programming, and I'm also part of that field, have been copying, borrowing, stealing sometimes, what's the terminology as well as the mannerisms of civil engineers, the real architects, right? We call ourselves software engineers. But the truth is that the way we write software is actually very different. The way that people build buildings or the bridges or tunnels, there the cost of an early mistake is very, very high. If you make a mistake in your architecture, the building will collapse, the bridge will tumble down, and the 2 different ends of the tunnel may never meet. This has actually happened. At the same time, in software engineering, we do not actually put that much thought into the initial design. The predominant philosophy in software engineering, the whole agile thing and all the other things, have been that, you know what, we can refactor it later. It's not that important. Small mistakes don't matter. Time to market is the most important. Ship it early, ship it often, has been the predominant philosophy in software engineering, which is very, very different from civil engineering. And the reality is that with 50 billion devices coming online, most of these devices, what are these devices, right? These devices obviously are your smartphones, but this is also everything from wearables, so your smartwatches, to Google glasses for the fortunate of you in the audience, or most of the cars by 2020 will have internet connectivity. A lot of people, at least in the US, have air conditioners that are connected, the Nest awesome conditioners. Everything will be connected. And when you have 50 billion devices, all of these devices are sending data to the cloud eventually through the APIs or are being driven by the APIs, right? So soon enough, you will be writing APIs that millions of devices are depending on. So if you make a mistake and you now need to change that field in the API, you're potentially breaking millions or tens of millions or billions of devices. You will not be able to do it. This is why it will be very, very important to build software that lasts for a very long time, to build APIs that are not versioned every 6 months, that do not break our clients. And the problem with that is that we're actually very bad at building software that lasts a long time. Most of us, myself excluded, are very good at building software in general, but version software, software that lasts 6 months or a year. And we're very bad at building software that lasts for a very long time. So why is that? According to Roy Fielding, who actually said that we're bad at building long-lasting software, the way he explains it is that the reason we're bad at building software that lasts for a long time is because most software is built using the implicit assumption that there is a single entity that controls everything that happens in that system. Or at least, if you have multiple entities, all of these entities are working towards the same goal. I'm quoting Roy Fielding. This is not my words. And the reality is that when you're building a highly distributed, complicated system, this assumption is completely wrong. You cannot assume that there is a single entity that controls everything, or even that every entity in that system is working towards a shared goal. They often work for the different goals or actually against each other. So this is complicated. But we actually have something to learn from. What is the largest, most distributed system humankind has ever built? It's not a rhetorical question. Somebody can answer? What was that?
Internet.
Internet, right? World Wide Web is a huge, highly distributed system, the largest, the most distributed system that humankind has built. And how long has it been around? 25 years. It has had the same basic architecture for 25 years. That's a very long time. What other software do you know that has been around for 25 years that we still kind of enjoy? It's not much. And as a matter of fact, the news are even better, that a whole bunch of very smart people have actually spent years investigating what is in the architecture of the World Wide Web that makes it so successful, so resilient, lasts for such a long time. Roy Fielding is obviously one of those people. There's also other people like Mike Amundsen and a whole bunch of others. And the answer to this question, what in the web's architecture makes it last for such a long time, is something called hypermedia. Hypermedia is the matter of which the World Wide Web is made. If you remember your high school physics, the actual physical world around us is made of myriad of elementary particles, right? The bosons and fermions. Very much like that, the World Wide Web is nothing else but billions of interacting hypermedia documents. Most of these documents right now are HTML documents that all of you are very familiar with, right? And HTML is actually very, very special media type. If you think about it, what is HTML? It's maybe a couple of dozen of very simple tags, right? Very simple rules that can be combined in an endless variety of manners and allows us to build anything from e-commerce application to your online banking to taxi service to entertainment, pretty much everything. But the underlying rules are just a couple of dozen of very simple tags that anybody can learn. That is really magical. It is very, very efficient and productive system. Imagine if we had something like that for APIs that also lasts for 25 years. Can we use HTML? Well, HTML is kind of created for rendering unstructured data. And in APIs, we're mostly dealing with marshalling around structured data. So HTML is not the answer. But the architectural trait behind the HTML web, which is hypermedia, is definitely the answer. And according to Roy Fielding, if we want to build highly durable distributed systems, the best thing we can use, the thing that we know works, there may be other things, but those are untested. Microsoft tried to create something in the lab called SOAP. We know how all that ended. This one we know works. Hypermedia works in a highly distributed system. So what is the primary problem with not building APIs with hypermedia, right? So the way that we build APIs right now. It's the coupling. Clients of the APIs know too much and depend on too much on the server. right? When you're building a typical API client, you're writing down the exact URLs that you need to get the list of users, or get the list of toys, or get the list of the government agencies. You're writing down and hard-coding these URLs. You're hard-coding the objects you're sending to the server. You're hard-coding the objects they are responding with, hard-coding the attributes of these objects. There's a very tight coupling between the client and the server. And this coupling means that it's very brittle, because as soon as you need to change something on the server, immediately the client needs to update or it's going to break. The coupling is the biggest toxic thing in this environment. But what if we didn't have to build things like that? What if the server could dynamically tell the client what client can do and how, guiding the client from one desired state to another? Then the client does not have to memorize all those things. And the server can change the URLs, server can change a lot of things, and the client will just learn because it's looking at the server for what those are. What we would need to do for this is that when the API responds, it shouldn't just respond to data. Most APIs now are responding with just data. What the API should respond with is the data and the metadata that tells us what else can we do with the API. If you think about it, the web is also a hypermedia system, right? How does the web work? Let's say we go to CNN.com or Lego.com, and we get the homepage. We get the main piece of content that we were looking for. What do we do next? Do we pull up a manual and try to find the URL in a printed manual to see what else can we do? No. It's all there, right? It has the forms, it has the links. Right there in the response, in the initial response, we get other things that we can do. But APIs don't work like that. The way APIs work, we memorize one URL, and if we need to do something else, we have to go and read the documentation to see where we get that URL. It is ridiculous. So to not do that, what we need hypermedia. And the way Fielding defines hypermedia is defined by the presence of application control information embedded within or as a layer above the presentation of information. Basically, he's saying we need data, but we also need metadata with the controls of what else API can do. So a lot of times when people talk about hypermedia and hypermedia APIs, you will hear the word affordances. Affordances is not really a word. It's a word that was invented by a guy called Gibson in the 70s. He was one of the most famous psychologists of 20th century, specifically concentrating on the field of visual perception. So he coined that word, and then that word was highly popularized by another guy called Dan Norman, who wrote the book, The Design of Everyday Things, a fantastic book. If you have not read it, highly recommend. But this is basically how they explain the affordances. Affordances is the object's way of telling you what it can afford, what it can do, what you can do with an object. So for instance, if you're looking at a chair, which all of us are, many of you are sitting on a chair right now, you don't need a manual. You know what it affords doing, right? You can sit on it, you can put your laptop on it. If you get really angry, you could throw it across the room. I highly don't recommend doing it, but you could do it. And all of those things, all of those affordances are communicated to you by just recognizing the objects. You don't walk in the room, look at the chair, read a manual of whether you can put a laptop on it or not. You know it can do all of those things because useful objects communicate affordances. This is how objects become useful in our environment. When we see a car, we know that in general we can drive that car. When we see a door, we know that we can open that door. Any door, right? We see a handle, we know we can probably do something with it. Those are happening because all of those objects, any useful object in the environment communicates affordances to us. And not only these objects communicate affordances to us, but there is also a pattern of familiarity, right? Many cars are very different from each other, but we know that all of them have a wheel, that if we turn that wheel, the car is going to turn. Most of them have pedals. If we push the gas, it's going to go faster. It's the same thing in any car. And the similarity is very important. The similarity is the reason why on English keyboards you are still using QWERTY. A lot of people think that QWERTY is a very efficient keyboard layout. It's not. It was created for typing machines so that the things would not get entangled. It's actually very slow to type, but people are used to it. It's familiar. right? So familiarity is very important. And an example of how important familiarity is, I usually drive a very small sporty car, Mazda. Mazda is not my sponsor. And I really, really like it. It has a nice engine, it has turbo, all those things. I can talk for days about it. And recently I had to move. I was living in Washington, D.C., I was moving to Philadelphia. So the way we move in America, we rent a truck, load all of our stuff, and drive, right? So a truck is very different from the small car I usually drive. If you want two cars that are the most different from each other, those cars are the most different from each other. And all I did was rent the truck, load everything, got some help loading, and just drove. I didn't read the manual, I didn't get the training, I didn't do anything. By knowing how to drive my small car, I knew how to drive a truck. I was not very efficient. There was no way that I would be able to parallel park that truck. I was praying all the way that when I arrive, there is no need to parallel park. I was terrified, right? I also got stuck because the handbrake on a regular car on a truck is a foot brake. So there were some things that were confusing, right? I couldn't do everything. I didn't become a trucker, but I could do the basic things. The reason I could do these basic things because those two objects have the same basic affordances. Do we get the same thing in APIs? If I build an API for Twitter, can I use any of that code to use the API for Facebook without reading any manual? Can I use any of that knowledge to read an API client for Twilio or Google without reading any manual or getting a training? I cannot. These objects, the APIs, are not well designed. That's a problem. So what we need in this space, we need media types that will capture the common vocabulary of things we can do. There's a lot of things that APIs do the same thing, right? A lot of APIs have pagination, have internationalization, have security, have all kinds of things that are really the same thing from one API to another API. But they all implement them differently. You have to read the manual to know how each one of them implements that. That is unnecessary. We can have the HTML of APIs, right? How does HTML work? You have one browser, and you go to any website, and you can render that website. We're not writing multiple browsers for each website. We can have a very close thing to that in APIs, but not exactly. And as soon as we mention the browser thing, a lot of people who are paying attention will say that, but hold on a second. With the browser, you have a human being. And human beings have eyes and brains. Very advanced computing systems, a similar thing of which we do not have in computers. And APIs are used for mostly computer-to-computer communication. So what is going to play that role of an eye and the role of a brain that can actually understand in real time some semantic meaning of the information presented? We don't really have that advanced of computers to do that, right? Most artificial intelligence systems cannot differentiate a cat from a dog. It's kind of insurmountable problem in artificial intelligence, and for a human being, that's very easy. So this problem is called a problem of semantic gap, that we can communicate similar things from one API to another. We can go very far there, but as soon as we enter the problem of the industry knowledge or the domain knowledge, we need some specific semantic understanding of that API that computers have very hard time figuring out. And we're going to solve this the same exact way we solve the problems of artificial intelligence everywhere else. Most of you probably have smartphones, right? So either you're talking to your Siri or Cortana or Google Now, but a lot of times you're communicating with them. Do they really understand what you're telling them? Is it really an intelligent system? No, it's not. It's actually pretty stupid. It has a limited vocabulary of things it understands, and then by interacting with millions of us, they are trying to learn more and expand their vocabulary. But most artificial intelligence systems, the way they avoid the shortcoming of it's not really as smart as a human being is by introducing a limited vocabulary of things they understand and mimicking very well, using that limited vocabulary, the interaction, the user experience of actually interacting with an intelligent system. We can do the same thing. We can create the vocabularies on top of media types for common things. We can create the vocabularies for specific industries and for specific applications. As a matter of fact, there is already an RFC standard that is dedicated to this. It's called profiles, which is layerable on top of a media type. So you could have a media type like HTML, and then you can have a profile like HCard or VCard for human information, or you can have a media type like Uber for APIs, and you can have a profile on top of it that is for news industry or the entertainment industry, or for specific applications that Lego is using. Profiles are those add-on layers on top of common media type communication layer that allow you to express additional semantics that is either industry-specific or application-specific. And there are standards for this. There is an HTML-specific standard called XMDP. So profile in RFC can be anything. As far as you communicate inbound the semantics of your application, the additional semantics, it is a profile. It can be human-readable, it can be PDF, it can be anything. They don't care. But there are some machine-readable profile definitions as well. So XMDP is for HTML. In public media platform that was created for news industry in the United States, there is a specific news-specific profile definition. And a whole bunch of people are now working on a standard called ALPS, which is a generic standard for defining profiles for any domain. It's very, very exciting. When that gets standardized, we'll be able to do machine-readable definitions of semantic things on top of base media types. Okay. This is kind of daunting. I mean, what time is it? It's not even 10. I'm talking to you, all of those things. I mentioned Roy Fielding. For crying out loud, the guy wrote a PhD, so half of the stuff I'm telling you is from a PhD dissertation, right? That's probably the last thing you want to be hearing this early in the morning. So it feels very complicated. And you may be wondering, okay, he kind of tried to convince us that now is the time, there's 50 billion devices, blah, 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 but do I really need to be doing something this complicated? And the reality is, it's actually not complicated at all. And as a matter of fact, all of you are very familiar with all of it. Because guess what is the perfect hypermedia system? Any website is a perfect hypermedia system that is using a perfect hypermedia type called HTML. Any website is communicating to you not only the content, but also the controls. It gives you the links you can click, it gives you the forms you can fill out and submit, it gives you the metadata to interact with that information. Those are perfect hypermedia systems. Kinlane mentioned that we're kind of like in 1996 in API ways compared to the human web. I would actually say we're probably in 1992. APIs are way backwards compared to where the human web is. So we're trying to learn now how to apply things that we know work in human web, how to use the same things in APIs. So all of those things you have already done in human web. We just need to write the systems the same way in the APIs. And here's the shortcut I use personally. I've been doing this for a couple of years now. I've had to build a lot of systems, but even to this day, I use this shortcut. Every time I get stuck with hypermedia APIs, because it's still very new, right? Most people don't write hypermedia APIs. So sometimes you start wondering, should I do it this way? Should I do it that way? Every time I get stuck, I just think, what if this was a website? What if it is not an API? Forget about API, forget about JSON. Think about, if it was a website, what would I do? And every time that you think like that, you're going to make the right choice. It's very easy because you all know how to build web applications. And hypermedia is all about web. So really, that's all it is. Just build APIs, just like you would build websites. But if you do want like a formal definition of how to build hypermedia APIs, there is a 7-step process that is in the book by Leonard Richardson and my colleague at API Academy, Mike Amundsen. They wrote an amazing, really good seminal book about RESTful web APIs. If you're interested in this space, you should definitely read that book. And one of the things they do, they define the 7-step process for building hypermedia APIs. It starts by identifying semantic descriptors, which is basically a fancy name of identify your resources and identify your representations of resources that you will be communicating through the API. So that's step number 1. You just need to know what you're messaging around. Step number 2, draw a state diagram of what's going on. We mentioned about it briefly that the server is guiding the client through different states by telling, you can do this now, you can do that now. Basically, the biggest thing about the hypermedia system is it's a finite state machine. It's a finite state machine where through sending messages, we're moving from one state of an application to another state. It's very easy. State means there was a user, had some username, we send a message to the server, now the username is something else, the state changed. Nothing fancy here. This is a UML diagram. Does it have to be UML diagram? No, it doesn't have to be UML diagram. Draw something that shows you what state changes your application can go through. If you were building a website before, you were doing it, it was called sitemap. Doesn't care. I'm not in love with UML, I don't care about UML, I just use it because it's the most common. Draw something that will allow you to understand what are the various flows in your system. Draw a state diagram. Reconcile names. Remember, commonality and recognizability is the core of useful products, and your APIs are products. So using the common names for the common things is extremely important, right? In HTML, we know what a tag stands for. In HTML, we know what form tag stands for. There's a whole bunch of standards for those things in APIs as well. There's IANA link relations, there's microformats, there is doubling core. Those things define a lot of common terminology. When you are designing your API, use common terms, because then the clients that were written for other APIs that also do the same thing will be able to just pick it up. They will be able to just use pagination in your API, just use internationalization in your API, do a lot of things by you just using the common names. So this is the step. If you're building something, you need to do something. First check, is there a common name for that? If there is, use that. If not, use a URL. That's what the step is. Choose a hypermedia type. There are a number of really, really good hypermedia types at this point. HTML obviously is one of them, but again, like I said, the problem with HTML, it's for unstructured data. There's a whole bunch of them that are JSON and are very well designed. And you have a list of that here. My personal favorite, and I'm hugely biased, is Uber. It's very new, but it has an amazingly small microkernel, amazingly extensible. But I'm also one of the co-authors of Uber, so don't trust me. But there is a list. You can choose your own poison. And basically, once you choose the media type, then you have to write a profile so that you have the semantics of your industry and your application captured. Then you obviously at some point have to implement your API. And then once you are done with everything, you have to publish all your documentation. And the documentation in hypermedia is very different from documentation in other APIs. In other APIs, you're documenting the specific URLs and the objects you send around. None of that is required in hypermedia APIs. All you need to document is the media type you're using. So you need to know your HTML, right? All you need to document is the profile, so for the additional semantic information, and that's it. Other than that, the clients will know what to do. The clients will be able to follow the URLs that your API dynamically communicates and follow the message types that you're dynamically communicating. The clients will be able to evolve with your server. You will be able to create systems that last as long as the World Wide Web. And so far, it has been going very strong for 25 years. So is anybody actually using it, right? So I'm on the stage, I'm preaching hypermedia API to you, but maybe I'm the only one using it. How do you know, right? No, I'm not the only one using it. There's a lot of very famous companies that you all know that are getting on the hypermedia bandwagon, are already using hypermedia bandwagon. So AWS Streaming API is implementing using hypermedia. There's a very innovative e-commerce startup in Canada called Elastic Path. Their whole stack of APIs is hypermedia. Comcast is a huge internet and content provider in the United States, owns NBC and the NBC Universal. So PayPal, a whole bunch of them are using it. And the last, if I sparked any interest in you about hypermedia APIs, this is where you go to find more information. You can follow Mike Amundsen. API Academy does a lot of tweeting about hypermedia APIs. We have Jason Harmon in the audience who builds hypermedia APIs for PayPal. Definitely talk to him. Kinlane, you have to follow Kinlane if you're in the API space. There are also links here that have list of things about hypermedia APIs. So there's a lot you can do. It's a very hot space. Thank you very much.
All right.